5, May, June, paper 43. Let's take a look at question number 1. We have two particles P and Q of masses 0.1 kg and 0.3 kg, respectively, are at rest on the smooth horizontal plane. P is projected directly towards Q with the speed of 4 u-meter per second. At the same instant, Q is projected directly towards P with the speed of u-meter per second. After P and Q collide, P move with the speed of 2 meter per second and Q move with the speed of 4 meter per second. Find the two possible value of U. So over here, we shall consider the two different cases over here. Case 1 is where the P and Q, this is the P, this is the Q, 0.1 kg, 0.3 kg. P is moving towards Q with the 4 u-meter per second and Q is moving towards P with the u-meter per second. So over here, case 1, we will assume that the directions of P after the collision is remain unchanged. That means the Q also going this way. Okay. So for this case, we just use conservations of momentum. We will get 0.1 multiply 4u plus the 0.3 multiply negative u is equals to the 0.1 multiply 2 plus the 0.3 multiply 4. So over here, you will get this one as a u is equals to the, you'll get 0.1 u, sorry. 0.1 u is equals to the 1.4. That means the u is equal to the 14 meter per second. Okay, so this is the case 1. Now we are going to case 2. So case 2, the situations will be like this. The P and Q, before the collision, they are moving towards each other. But after the collision, the direction of P is reverse. And the directions of Q is reverse. So over here, again, conservations of momentum, you will be having 0.1 for u plus the 0.3 negative u is equals to the 0.1 negative 2 plus the 0.3 4 meter per second. So you get 0.1 u is equals to the 1.0. So your u is 1 over 10, or you can write 0.1. So these are the two possible answers. Is there possible to have a third case? Okay, if you have a, let's say maybe some of you will asking, is it possible that the Q and P, they are moving with these directions after the collisions? Okay, so is it possible to have this case? Possible, but if you have this case, then your result will be the U is equal to the negative 14. Okay, if this case, then your U will be a negative 14. Okay, but this is the question is looking for the speed. Okay, the U is a speed. So negative 14, positive 14, we consider as the same answer. So we will not going to consider this case. Okay, so this case is not going to consider. That's all. Okay, so these are the two cases and these are the two possible value of U. That is the answer for question number 1. Now we move on to the question number 1b. Find the largest possible loss of KE in the collisions. So the largest possible KE, that means the KE initial must be as large as possible. So the U, we will take the largest, okay? So for the largest KE loss. So for the largest KE loss, is equal to the half of the MP, which is 4 times the 14, 4u square, plus the half times the 0.3. Sorry for that. I should try to fit in everything. Maybe I just write largest KE loss is equal to the half of the mass of the P, the 4 times the U square, plus the half times the 0.3 multiplied by the U square, minus the half of 0.1 of the 2 square, minus the half of the 0.3 of the 4 square. Then you just need to press a calculator. Okay, so over here, one by one, 156.8 plus the 29.4 minus a 0.2 minus a 2.4. So if you press a calculator, then you will get 183.6 joule. This is the largest of the KE loss for the question number 1B. Moving on, we have question number 2. We have a van of the mass 4,500 kg towing a trailer 350 kg along along a straight horizontal road. The van and the trailer are connected by a light rigid tow bar which is parallel to the road. There are resistant forces of the X Newton on the van and the 120 Newton on the trailer. The driving force produced by the van engine is a 2,500 Newton. The tensions in the tow bar is D Newton and the accelerations of the van is 0.4 meter per second. So maybe we can draw a diagram. So we have a trailer, then we have a van. Okay, so the van, the engine produced by the van is 2,500 Newton. You have a resistance force for the trailer is a 120 Newton. The resistance force of the van is a X Newton. Then this is a D, this is the D. Okay. This one is a 4,500 kg. This one is a 350 kg. Anything else we are missing? Okay, we are moving with the accelerations of 0.4 meter per second square. Okay, so these are the information given. So what we need to do is that we consider the whole. Okay, so if you consider the whole, if you resolve the forces, that means the van and trailer. Okay, the van and trailer together. So you will be having the driving force minus the resistance force of the trailer, and the resistance force of the van is equal to the net force of MA, which is a 350 plus the 4,500 Newton, 4,500 kg multiplied by the accelerations. Okay, so over here you just need to calculate it. Okay, so over here you will get this as the X is equals to the 2,500 minus a 120 minus the 1940. So your X will be equal to the 440 Newton. Okay, so we found the X. Then we need to find the T at the trailer. Okay, at the trailer only, because the trailer only itself, the T is here. This is the 350 kg. And this is the 120 Newton. Okay, so at the trailer, if you resolve, maybe this one we should highlight, trailer and van. Okay. So for this case, at the trailer, if you resolve the forces horizontally, you have a D minus a 120 is equal to the 350 of the A. Then you get the D is equals to the 260 Newton. Okay, just press a calculator directly. Done. This will be the answer for question number 2. Now we're moving on to the question number 3. Over here, showing you velocity against time graph, which the models of the motions of a particle. The graph consists of 3 straight line segments. Velocity of the particle at time t second after passing a fixed point O is a v meter per second. The particle leaves O with a velocity of 5 meter per second and accelerate at a 0.35 meter per second for 20 seconds. The particle then decelerate for the next 30 seconds. At the t equal to 40, the velocity of the particle is 0. After t equal to 40, the particle starts to travel back to O and come to rest at O at time t second. Find the value of t. Find the value of t. So over here, first of all, we need to calculate this value. Okay, we need to calculate this value first. Okay. So to calculate this value, we have a stage 1. So we have a v is equals to the 5 plus the 0.75 t. Okay, so this is the acceleration is based on the questions given. The time is also 20 seconds. It's also given in the questions. Press the calculator, then you will get this one as a 20 meter per second. That is a v. Then stage 2. Stage 2, I need to calculate the value over here. I call it W. Okay, so this one is a decelerations. Stage 2, we are having the acceleration as this point. Oh, maybe we consider or 20 to 40. That will be easier for us. Okay, that will be easier for us. I want to calculate the decelerations. This point is already known as a 20 and 20. This point is known as a 40 and 0. This point is known as the this point is known as the 50 and W. Okay, so stage 2. Okay, I think stage 2 we can do it like this. Stage 2, we are having the gradient for this portion and the gradient for this portion are the same. Okay, so the gradient it will be 0 minus a 20 over 40 minus 20 is equals to the W minus a 0 divided by 50 minus a 40. So you will get this one as a -1 equals to the W over 10. So W is equal to the -10. Okay. Then what else we can do? They mentioned that it starts from O and it's coming back to O. That means the total displacement must be 0. Okay, that means the displacement over here, the area over here, and the area over here, they must be the same. Okay, that is the meaning of it. Okay, so we just say that the given that the total displacement is equals to 0. Okay, so that means the S1, okay, is the time from 0 to 40. The distance travel is S1. So I will use the formula area. Okay. This is the S1. This is the S2. So the S1, I will use the area formula. Trapezium plus right angle triangle. So we have a half multiplied by 5 plus 20 times 20 plus the half times the base times the height. So you will get this one as a 450. Then for the 40 to t, your S2 is equals to the half times the base times the height. Okay. So you will get this one as the 5t minus the 200. S1 equal to S2. That means 450 is equal to the 5t minus the 200. So the t will be equal to 650 divided by 5. That will be 130. Done. This will be the value of t. That is the answer for number 3A. Moving on, we have 3B. Find the accelerations of the particle from t equal to the 50 to t equal to t. Okay, we want to find the accelerations over here, the last stage. Okay, so the stage 3. Actually, it's quite simple because you already have the coordinate. You already have the coordinate. This one is a t is 130 as a 0. This coordinate just now is 50 and negative 10. Okay, so stage 3, your accelerations will be the 0 minus the negative 10 divided by 130 minus a 50. So you will get 1/8. Okay, meter per second square. Done. This will be the accelerations. Okay, so now move on with question number 4. B blocks P and Q of masses 25 kg, 20 kg, and mkg respectively, held in equilibrium by 3 line inextensible string OP, OQ, and OR. Strings OP and OR both pass a small fixed smooth pulley, and pulleys A and B respectively. B and R hanging vertically below the pulley. Block Q hangs vertically below the point O. The angle between OA and the vertical is 30 degree, and the angle between angle BOQ is alpha degree. See the diagram. Find the values of the M and alpha. Okay. So what I need to do is that I need to have the forces diagram over here. So let me just draw it. Okay. So one by one. This is the mass. This is the weight. This is the weight. This is the weight. So at P, if you resolve the forces vertically, you have the dP is equal to the 250 Newton. Okay, dP is equal to the 250 Newton. Then at Q, if you resolve vertically, you will have dQ is equal to the 200 Newton. Then at R, if you resolve vertically, you will have the dr is equal to the mg, which is a 10 Newton. Okay, that is the things that we need to ready. Now at O. At O, maybe we can have a diagram to illustrate the situations. So this is the dP. This is a 30 degree. This is the dQ. And this is the dr. This is the alpha. This is the dr. Okay, so this is what we have. If you resolve the forces horizontally, you will have the dP sine 30 is equal to the dr sine alpha. So it will be, just now dP is how much? dP is 250 multiply half is equal to the 10m sine alpha. So you get m sine alpha is 12.5. That is equation 1. Then if you resolve the forces vertically, you have the dp cos 30 is equal to the dq plus the dr cos alpha. So you will get 250 set 3 over 2 is equals to the 200 plus the 10m cos alpha. So you will get m cos alpha is equals to the 12.5 set 3 minus the 200. Okay, sorry. Divide by 10. So it's not 200, it's a 10. That will be your second equations. So I want to find m and alpha. So to find the, I think I find alpha first. Number 1 divided by number 2, you will get tangent alpha is equals to the 12.5 divided by 12.5 set 3 minus a 20. Press the calculator, you can get the alpha is 82.5 degree. Okay, 82.5 degree. Then over here, you replace them back into the equation 1 to get m sine 82.5 degree will give you 12.5. So press the calculator again, you get your m is equals to the 12.63 significant figure. Done. This will be the answer for the question number 4. And moving on, we have question number 5. 2,500 kg traveling at a speed of v meter per second, experiencing a resistance force of kv square Newton. The constant power of the van is produced by the engine is 62.5 kilowatt. We have a steady speed and the van could be maintained when moving the straight horizontal road is 50 meter per second. Show that k is equal to 0.5. After that, we want to find the accelerations of the van when the speed is 25 meters per second. So we have 2 cases over here. So that means we just need to mention that when the v is equal to the 50 meter per second, your driving force, to resolve horizontally, your driving force is equals to the driving force minus the resistance force is equal to the MA. Your driving force, it will be given as a P over V minus the FR is equal to the MA, is equal to 0. Okay. Because we have a constant steady speed. Because of steady speed, your acceleration will be 0. So your resistance force will be equals to the power 62500 divided by the V. So you can see that your resistance force is, you can get your resistance force is, oh, sorry, I make a mistake. They telling you that your resistance force is a kV square. So I need to write kV square. Okay. So it will be kV square. Therefore, you can get your k is equal to half shown. Okay, but the question mentioned 0.5. So we show that the k is a 0.5. That will be better. Okay, so this is how you find the k, and then now we want to find the accelerations when the v now has become 25 meter per second. So again, if you resolve the forces horizontally, just need to change the driving force to become your driving force will be 62500 divided by 25 minus the K B square is equals to 2500 A. So from here, just press the calculator directly. You can get the A. So your A will be 7/8 meter per second square. That will be your accelerations. So now we move on to the B. The van begins to ascend a hill inclined at an angle theta degree to the horizontal. The van travel along a line of the greatest slope of the hill. The speed of the van at the start of the hill is 20 meter per second and accelerations is 5 meter per second square. Later on the same hill, the speed of the van is 30 meter per second and the acceleration is meter per second square. The power of the vans of the engine is remain the same, 62.5 kilowatts, and the resistance force remain as a half V square Newton. So we want to find the value of the theta. Okay, so we just need to, maybe we can draw a diagram over here. So at here, your speed is 20. At here, your speed is 30. Your A2 is a A. Your A1 is a 5A meter per second square. Okay, so this is the diagram, but the diagram actually not needed. Okay, so when the V is equal to 20 meter per second, your accelerations is equals to the 5A. Okay, that is the first stage. Okay, so your driving force, it will be 62,500 divided by 20 minus the KB square is equal to the 2,500 multiplied by 5A. So over here, if you, oh, I forgot, there's one more thing over here. There's one more resistance over here. Because you're going up the hill, there will be the mg sine theta is equals to the ma. So your mg sine theta, I will just write it as a 2,500 times 10 sine theta is equals to the 2,500 5A. Okay, try to squeeze in everything. 2,500 multiplied by 5A. Okay, so we just press the calculator and to simplify it, you get 2,925 minus the 25,000 sine theta is equals to the 125,008. I call this one equation 1. Then at another stage, when the V is equal to the 30 meter per second, your A2 is A meter per second square. So for this case, my directions of the forces is wrong. Supposed to be going up the hill. Supposed to be going up the hill. So it will be the driving force still, the power is still 62,500. But this time your velocity is 30 minus the KB square minus the mg sine theta is equals to the 2,500 A. And then we simplify it. So actually over here, nothing much to simplify. We make it 4,900 divided by 3 minus the 25,000 sine theta is equals to the 22,500A. That is equation 2. So I let them, I just take 1 divide 2. 1 divide 2, I get 2925 minus the 25,000 sine theta divided by 4900 divided 3. Just solve the simultaneous equations. You don't have to follow my way of solving the simultaneous equation. So you can substitute over here. I try to eliminate. Okay. So this one you will get this as the 12,500A divided by 2,500A. So I cancel this. I get a 5. Okay. So then this one I will get 2925 minus the 2,500 sine theta, 25,000 sine theta is equals to the 24500 over 3 minus the 12500 sine theta. Okay. So at the end you get 100,000 sine theta is equal to the 15725 divided by 3. Then you can get your sine theta is equals to the 0.052417. Your theta will be 3.0 degree, correct to 1 decimal place. Then from the equations 1, since I have found the sine theta, since I found the theta is equal to 3.0 degree, I just need to replace it back into either equation 1 or equation 2. Over here, I choose equation 1. Then I will just get this as a 2925 minus the 25,000 sine theta. I use this value, more accurate. Is equals to the 125,000 A. Press a calculator, then you can get your A as a 0.129 meter per second square. Done. This will be the accelerations. Okay. So we have found the theta and the accelerations. That is the answer that we want. Okay, so this is the answer for the question number 5B. Move on, we have question number 6. Diagram over here shows the vertical cross sections of ABC of a rough water slide. Okay, so the sections AB is a straight line of length 5 meter inclined at an angle theta to the horizontal, where the sine theta is equal to 0.8. The point B is a 2.5 meter above the level C. A man of 80 kg model as a particle slides down the water slide, starting rest from A. Coefficient of frictions between the man and the straight sections of the water slide is 0.1. Find the speed of the man at B. Okay, so the speed of the man from here to here. What is the V? This is the U. As C is a 0. So over here, we can consider at somewhere your weight of the man is 800 Newton. This is the theta. This is the normal contact force of the man. And this is the frictional force, Fr. Okay, first of all, they give you sine theta is equal to 0.8. We just write the sine theta. 0.8 means it's a 4 over 5. From here, we build the small right angle triangle. So that it's easier for us to do the calculation. So for the A to B, So if you resolve the forces perpendicular to the water slide, so you have R is equals to the mg cos theta. That will be 800 3/5. That would be 480. And your frictional force is actually maximum frictional force is mu R is equals to the 0.1 multiplied by 480 is a 48. Okay, so we have found the frictional force. If you resolve the forces down the plane, you will have the 800 sine theta minus the FR is equals to the MA. So 800 sine theta is 4/5 minus the frictional force is equals to the 80 of the A. So from here you can find your acceleration is 7.4 meter per second square. So we use the Stewart equations. So at V square is equal to the U square plus 2AS. That means it's V square is equal to the 0 square plus 2 multiply 7.4. The distance travel is 5 meter. So therefore you get the V is equal to the square root of 674. Or you can give me the answer in decimal, 8.60 meter per second. Done. This will be the answer for the number 6A. Moving on, we have a B. It is given that the entire, there is no change in the speed of the man when passing through the B, and his speed at C is 11 meter per second. Find the work done against the resistance force as the man moved from B to C. So if you're moving from B to C, we know that the B over here, your speed is square root of 74 meter per second. At C, your speed is 11 meter per second. So the height over here is 2.5. So we need to use conservations of energy. The diagram over here is not needed. So conservations of energy. We have the GPE loss, okay, between from B to C. Okay, so the GPE loss is equal to the KE gain plus the work done by the resistance. So the GPE loss is mgh. The KE gain is a half m of the V square minus the U square plus the work done by the resistance. So the M is 80. The G is a 10. The height is 2.5. The mass is 80. The V square is 11. The V is 11. The U square is a square root of 74 plus the work done by the resistance. So once you have all this value ready, it's actually quite easy just to press the calculator. So you can just press the calculator, everything, your work done by the resistance, it will be equals to the 120 joule. Done. This will be the answer for number 6B. Moving on, we have question number 7. O is S meter, where S is given as 0.3 t squared plus 0.6 t for the time between 0 to 4. So we want to find the velocity when the time t equal to 4. So to find velocity, we need to do the differentiations. ds dt, it will be 0.6 t plus 0.6. Then at the t equal to 4, your v is equal to 0.6 times 4 plus the 0.6. That will give you 3 meter per second. That is the answer for the question number 7A. Moving on, we have 7B. Now the time is greater than 4, t greater than 4. The accelerations of x at time t second after leaving O is a meter per second square, where the a is given as 0.3 t power half. There is no change of the velocity of x at the t equal to 4. And at t equal to uppercase t, the velocity is 14.2 meter per second. We want to find the value t. So now over here, your a for the t greater than 4, your a is given as 0.3 t power half. We need to find the velocity. That means we need to integrate. So if you integrate, you will get this one as the 0.3 t power 3 over 2 divide 3 over 2 plus a c. Simplify it, you will get this as the 0.2 t power 3 over 2 plus c. Then when the t is equal to 4, your velocity is the same as the part A just now. Part A just now, the v is a 3. So you get a 3 is equal to 0.2 and 4 to the power of 3 over 2. So you get your c as 1.4. Okay, c is 1.4. So I get the velocity over here is 0.2 t power 3 over 2 plus the 1.4. Now, given when the t is equal to uppercase t, your velocity is a 14.2. So you get a 14.2 is equal to 0.2 uppercase t power 3 over 2 plus the 1.4. So just press the calculator, you can get t power 3 over 2 is actually a 64. That means the t is actually 64 power of 2 over 3. That will give you 16. Done. This will be the answer for the t for the number 7b part 1. Now we're moving on with the 7b part 2. We want to find the total distance traveled from 0 to t. So to find the total distance traveled, we have the stage 1. Your S1 is equal to the 0.6. Just now the S1 is 0.3 t squared plus 0.6 t. Okay, so we need to find the distance S1 over here. 0.3 t squared plus the 0.6 t. Press the calculator, you get 7.2. That is your S1. Then for the t greater than 4, okay, that means actually between 4 to 16, we have a S2. So for S2, we can integrate 4 to 16. Just now the velocity is 0.2 t power 3 over 2 plus 16, right? No, plus 1.4. Plus 1.4. Okay, so we need to integrate the whole thing over here. So you will get 0.2 t power 5 over 2 divided by 5 over 2 plus the 1.4 t from 4 to 16. Okay, so maybe we can, I prefer to make it become fractions. So we have a 2 over 25 t power 5 over 2 plus the 7 over 5 t from 4 to 16. Just substitute the value inside here minus this. Oh, not enough space. You put the 16 inside, and after that you put the 4 inside. Okay, so you just need to press a calculator. Then you will get this as the 96.16 meter. Okay, that is your S2. Okay, so therefore, total distance travel is equal to S1 plus S2 is equal to the 7.2 plus the 96.16. You get the answer as 103.36 meter. Done. This will be the answer for the number 7B part 2, and this will be the last question for this paper. So I will stop the video here. I'll see you next time. Bye-bye.